Welcome back to Umar Academy, and today we're going to be going into our biological sector, specifically biotechnology, and today we're going to be looking at embryo stem cells and research and cloning. So, this is what we're going to be looking at today. So, what exactly is an embryonic stem cell, and how do we define an embryonic stem cell? Well, we can define an embryo. We can define an embryo basically a eukaryote in the process of development. We could even say in fertile development. And then of course we have our stem cell. This is the holy grail of cell. And basically a stem cell is just a biological cell that can be used for anything. So for example, it could be a liver cell, or a heart cell, or even as complex as a brain cell. Okay, so that's a little introduction of what we're going to be doing today, and we're going to be focusing in on Sweden specifically. This was my country of choice and my topic of choice, and why did I pick this topic? Well, being someone who's interested, let's just have some fun. Here's me. And what do I like? Well, biology is definitely my favorite school subject. Nothing even comes close to it. You can even dig deeper. Biochemistry, even physiology. These are definitely not even just my favorite sectors in school, but pretty much my whole life revolves around biology, and I put a lot of time into understanding food and nutrition. So something like this would definitely interest me, and of course cloning. I mean, that's like the coolest thing ever. Who doesn't want to learn how to clone? We talk about this in childhood cartoons, and we see like these cities where everyone's flying around, and there's just clones of everyone just in these cartoons. Well, maybe one day we can actually get there, and this is just one step closer to it. So the rationale behind why I did choose this topic, that's definitely the rationale behind that. Why did I choose Sweden specifically? Well, I chose Sweden. Nice little color here. Well, for one reason, it's legislation. We'll go over some of the ethical codes and some laws later, but anyways, embryo stem cell research is very controversy. There's much controversy about it on a global scale, and there isn't really many places that actually have legal research. Here in Canada, we actually do not allow any embryo stem cell research whatsoever. We believe that it is inhumane and unethical, because essentially you do have to pretty much, you're killing a human before they even have the potential to grow, in order to get these stem cells that will be used in medicine. So at this point, it really comes down to what one may believe, what is better, either taking one life and potentially saving multiple, or like does that one life, does that outweigh saving others? So in Sweden, they believe that saving more lives is better, and obviously that's why it is legislated. As well as their economic state. Could even go as far as education. You could say that they have one of the most advanced educations in the world. They have free education, so people are going to be taking advantage of this, and there's going to be more people in school, more people in post-secondary school. So evidently, you're just going to have just a highly educated population just as a result of that. They are one of the richest countries in the world. They are in the top 5 richest countries in the world, so they do have a lot of money. So what I decided, what I thought about is, if they have lots of money, and they have lots of brains, well, what can they do with this in regards to cloning a human being? Is it possible? Can they still do this with all the resources? Well, that's what I decided to try and find out. Okay, so we'll move on to how this process actually works. And after that, we'll go back into the conversation of Sweden itself. So we're saying there's this god, this stem cell, that is just the holy grail, you could say, of cells. If there was a holy grail of cells, and we can pretty much take this stem cell. Say there's a cell, and we could turn it into a circulatory cell. Maybe a nerve cell, assuming someone may have nerve damage. Immune system, why not? Organ cells. You could even go more specify that. A liver cell, possibly. So all of these, all coming from pretty much the origin of one stem cell. Now that is fascinating to me, and if that's not fascinating to you, then maybe you need to reevaluate what you value. Anyways, so how does this process actually work? So we're going to take this guy right here, and we're going to say his name is Len. And what Len is going to do is he's going to give a skin cell. He's going to donate a skin cell. Let's say he has let's say he has Alzheimer's. So he needs, what does he need? He needs a brain cell. He needs some brain cells. He needs some fresh brain cells to clear up his Alzheimer infected cells, pretty much. So he's gonna give us some of his skin cells, and we're gonna take an egg donor. So female, of course, and she's gonna donate a fertile egg. However, the DNA from this egg is going to be removed. DNA removed. Deoxyribonucleic acid will be removed from this egg. Okay, so we're going to infuse this skin cell, Len's skin cell, with the, I guess it'd look more a little bit like this, the egg. And after time, this cell is gonna want to grow, and it's gonna want to pretty much it's just gonna want to multiply. So after being inserted through the outer membrane of this egg and chemically induced, um, there's this we call this a 5-day old embryo. So what is this? This is a blastocyte. So after a while, it's going to sit in there for about 5 days, and then we're going to have these blastocytes, and these are just 5-day-old embryos. Keep in mind that this is all just originating from one little skin cell, and so we have this expanding, or not really expanding, or multiplying rather. So multiples of these, and this is our mass of stem cells. Okay, so then what people in a lab are going to do is they're going to isolate these cells. This is all theorized currently, but this is the potential amazing theory, and it's going to revolutionize medicine as we know it. So we can take this, and we can dedicate this to brain cells. So keep in mind, since the cell originally, or the skin cell originally came from Len, it is gonna be his cell still. It is still his DNA, and that's pretty much what we're going for here. So he needs his brain cell for his Alzheimer's. So this is ultimately the need, but maybe it's possible that later on he develops some liver damage. So we're gonna have some liver cells. You could also use these cells for other people, but